Joe, okay. All righty. Start your recordings.
We are live, gentlemen. Let's change the future.
Go ahead, Joe, do the introductions.
Out of the darkness comes Cleef, a Frazzle and Joe with information that would change the world. All yours.
Okay, no problem. Anyway,
I'll redo it. You want to redo
no,
it?
that's fine. It's great. You know, each one has to be a little bit different to keep things lively. Anyway, in the previous videos, we first talked about the concepts of the toroidal interactions of plasma fields, and where we're stacking and multiplying plasma fields instead of just adding 1 plus 1 to the drive of each of the energy plasma fields. We're not going to go and start multiplying. The notion of the idea is we want to go from, instead of 1 plus 1 on the units, to go from 1 to 2 times that amount, or 10 times that amount, or 100 times that amount, or 1,000,000 times, to where the system is in balance, but it only takes a photon of thought to make the system move, to make everything start to happen. The idea is to get, if we get a spaceship put together and it's balanced, and a little flea crawls underneath the spaceship and jumps up and bonks his head on the floor, it actually moves the spaceship up in the air a little bit. That's the idea, to keep it balanced perfectly. Now, to get that to happen, all the numbers have to add up. All the progressions have to add up. I don't care whether it's the numerical ones or the acid-base ones or the CH3C2s, those Gans progressions all have to set up in the right order to make the system work. We don't want any back pressure. We want everything multiplying forward. So today, we started off first with the ideas, then we went into the wiring of the static generator and the hookups with the maggrav coils to do the multiplications. What we'll be talking about today is the Gans progression. And primarily, we're going to start with how we're going to Gans the coils, because if you do it wrong or in the wrong order, it's not going to work. We're basically trying to get the plasma to voluntarily move ahead from one section of the equipment to the next one, and set up a loop, or an infinity loop, or a tumbling effect, a rotation that is almost self-sustaining once it gets going, because we're going to be tapping off of that rotation for everything else that we'll be doing later on. This is the core, this is the static, this is the generator, the heart of the systems. I'm going to go and pick up a drawing now. Go to share photo. It's going to take me a moment. This particular device is a little bit slow. And the image that we're going to work with today is this one. Change colors. When we, in a quick review, this is the Rook formation, which is the static core of our unit. Change color. On the outside, we have, get it to draw, one there, one circle there. These, at first, were representing the plasma fields, and in this case, they're going to represent our maggrav coils, so that in your mind, remember that it goes clear around the top of the Rook. The first one at the top is going to be the one with the iron center on it. That's why it's got that color. The second one, which is a little bit bigger, is in the middle, and this is the B. Top one is A. The third one, and we change color, is the larger one. This is, oops. Oh well. Change color, I want green. At the bottom. This is going to be the one with the aluminum core. So that's C. And go back up to my first color, which is A. The iron center of the A, which is going to be your gravitational, taps into the copper wire. You draw that in pink, which is the spring up the middle. Of the Rook. Excuse me, I'm going to sneeze. The that one runs around the middle. The Rook in the middle, in the static core, there is a band of copper in the middle that is not tied to the maggrav cores outside it. And then the same thing at the bottom of the Rook, of the static core, right there, is aluminum wrapped around it that is not attached to the maggrav cores. They're just there, and we'll go at a later date why those three bands are in place. Back to our red color. If we take our Ganses, the ones that we have available is going to be the CH3. Your other one is going to be in pink, is, and we'll drop it at the bottom, CuO, and the last one that we're going to be using, change color, is, for right now, it's going to be a little bit different because you'll see why. We're going to use your CO2. And actually, I screwed up. Let me go to color. Blue. CO2 in blue. The other one that we'll be using is your Gans of aluminum, which is your, I don't remember the symbol of it, this aluminum Gans. And I'm going to set that, just remind, we've got that one sitting there. Your center core is going to have around the copper wire, copper spring wire, between the copper outside of the Rook and the inside. That's going to be your CH3 with the hemoglobin, with possibly neodymium and your amino acids. It's going to be a fairly heavy, pasty Gans, packed in as best as possible. We want it to be in the more solid state. We're going to have that. It'll have all the heaviest of the gravitational properties of the CH3 in that location. What we'll be dipping our coils in, which is A, B, and C, and I'm going to change how we designate those. We're going to call the light portion, or the plasma part of our Ganses, the liquid, clear liquid, is going to have a M with a circle around it, and then it'll have either a plus or minus designator as we progress. And what that means is you're dealing with the magnetic state, or the lightest Gans portion of that particular type of GANs for what we're going to be doing with. So when you see the designation CH uppercase, CH, I can't remember what it's called. Anyway, with the 3 erased, with the plus, there'll be a space between it, and then the plus, and then the circle M. That will designate that we're using the clear water, the plasma GANs of CH3. If it shows CH3 without the circle M in it, then we're dealing with the heavier portions of it, the different colors that you see, so, you know, the stuff that precipitates at the bottom of your jar. And so in the first coil up here, we are not going to do anything with it at this point. We'll get back to that in a minute. We are going to take our CH3 with the plus M, and that's the clear, and we're going to GANs B with the CH3 liquid, the plus M. We go down to C, change colors, and we're going to use CuO, and my plus minus may be wrong because I haven't gotten that far yet, circle M, and we're going to GANs C with it. When we get to the point where let me get my colors right, my green, from the gravitational aluminum wire from the inside of C, which comes around and attaches as a capacitor on the center portion of the Rook, where that loops in and goes around and makes its connection, we are going to use where's my blue? Either we're going to use CO2 right there. CO2M. Oh, did I do that right? No, I didn't get the right. My bad, my bad. Get my colors straight. Yeah. Yeah, CO2M goes in that position. And then when we run up to the top and everybody pause, please. We're going to come back for a minute. Pause because we had to make certain. Yeah, we're back again. We had to make a pause because this is so technically important that we don't want to make a mistake on the explanation of it. I'm going to go and get my drawing again, my drawing. It takes a minute to bring this up. Excuse my sniffles. We have our shape, and I'm going to start doing the annotation so we have everything back to where it was. This is our center that looks like it has that rook shape, we call it. It's like a bishop, but rook shape. This is our static core. Our top maggrav has an iron core in it. It's gravitational. And that's we designate with the brown. Change color. Our copper. Oops. Didn't get my color. Our copper is the middle one. Remember, it goes all the way around, so it's on both sides. It's a little bit larger. Change color to green. got it. This is our C, which is even larger, and that's our copper with aluminum center. So this is C. I'm going to put our which maggraph core we're going to be talking about on the right-hand side. So I don't have to erase it. C is at the bottom. B is in the middle. And then A is the top coil. Let's say up there. We'll start with our Ganses. On the inside, we're going to use from the Gans solutions, we're going to use CH3 hemoglobin Gans to bathe our copper wire that's on the inside, which is the coil spring. And I'm going to draw that in so that we have it. Remember, there's a kick that goes up through the middle. There's 3 layers on the outside of the unit of the Rook. The top one is the iron wire, the middle one is the copper wire, the bottom one is the aluminum wire. The only one that's attached at any point to the maggrav system is the iron one at the top. And change colors. So that wire on the iron on the gravitational connects to the iron wire on the outside of the Rook. The aluminum wire at the bottom, and these are each one of the, so still got the color, so the wire comes down, attaches to the gravitational core of the B, which is copper, and that goes down, and that gravitational is connected to the gravitational of the center wire of the aluminum, which is the gravitational of the aluminum, and the aluminum wire comes off the bottom and attaches like a capacitor to the bottom of the Rook before it gets to, I'm going to draw it in black. I think it's going to work. Which is going to be the lead Gans at the bottom. The copper wire, which is the antenna wire. Let me change the size of my pen a little bit. And we're going to get back to the center wire in another video before we start construction. I'm going to run that up through the middle, like so. So we have all our components. The aluminum wire attaches to the outside of the plastic sheath around our antenna wire in the middle, the plastic. So it acts like a capacitor. The aluminum wire coming to the center comes around and attaches. Oops, wrong color. Green. Right there, the aluminum wire attaches to the plastic tube that it goes around the center antenna wire. So those are the components and how they're set up. When we start to do Gans, Gans has 2 major components to it. It actually has 3, but for our example, because we're working almost with a 3D tangible material, it's almost like a solid state or a matter state, and we're trying to convert it into plasma state. We're going to be dealing with the Gans that goes at the bottom, which will be our regular designators. And I'll start with our CH, and I would like you to get into the habit of putting the number higher in superscript 3. That's your CH3. And I'm really pushing for that designator. You will have a space between the H3 of that symbol to when we're dealing with the plasma Gans, which is the clear liquid off of the top of your Gans collection tubes. And we'll get into detail of what we're going to do with that clear liquid prior to doing the Ganses later on. But just for the designator, we are going to use the symbol M for magnetic, because it's the lighter part, with a circle around it. And that's going to be, when you see a demarcation, especially for this group of CH3 circle M, it means we're dealing with the plasma Gans, or the liquid that is basically water that has the memory of the solid Gans is at the bottom. The next thing that we're going to add in our nomenclature is the plus minus symbol, and it's going to be superscript above the circle M. And for CH3, the circle M, just because I don't know and don't have it fully thought out, we're going to give that one a plus. As we get further in with our plasmas, the plus minus will probably be the pH of your liquid Gans as a designator. So if it's acidic, it'll be a minus, and if it's a alkali, it'll be a plus. And it's really, really, really important, and it'll make more sense as we go on and as we develop in plasma technology. You would think that you would put your CH3 circle M Gans on the top, or the A circle. That would be incorrect. You don't set up a gradient that way. We're going to set up our CH3, our clear water, on the entire Maggrav coil, that's the inner and the outer, of the B. So the CH3 is going to be on the B. The CU, let me change this now to pink, and we get CuO, and we're going to be using circle M. The CuO is probably negative, if I remember correctly. So they'll have a designator at the top as a minus. That's not going to go on B. No, it's going to go on the C coil, right there. The clear plasma, the water that has the impression of the CuO Gans, is going to lace the copper aluminum coil. Where the next one comes in, I'm going to do this in blue. And that's going to be your CO2, remember superscript, circle M. That Gans is going to go on the junction. It's super, super important, of where the aluminum wire comes in contact with the plastic sheath of the protector that's over the top of the antenna. And that'll have to be added on right after it's after everything's assembled. It's one of the last things that gets put on, is that one. We have lead in the bottom, lead Gans. But lead Gans comes in two forms. It comes in the solid, and it's heavily gravitational, but it also has a clear portion of it. So we have a PB. Remember this one? Lead, P. Get my the other way, a B. Anyway, PB is lead Gans, and we're going to use the plasma, the clear part, so that's going to be a circle M. And I haven't done a pH on it, so I don't know whether it's plus or minus. I'm pretty solid, you know, in my mind, I'm sure it's a minus, but that Gans is going to go on the A coil up here on top. And so we have a progression. If we review back to our antenna, which is a nano-coated copper wire, and that copper wire should be fairly large at this point for what I'm understanding on the system. So we may be looking at something that's, if you built all your maggrav coils out of 14 gauge, you're going to be building your center antenna wire out of 10 gauge or possibly 8. It's going to get rather cumbersome to work with because you're still going to have to spin a coil down at the bottom. Let's see, down in this area, you're going to have to spin a clockwise coil to go down into the heavy lead Gans at the bottom, the heavies that come out of the solution. That's the heaviest of the heavy lead Gans that goes down at the bottom. Review, we have the plastic sheath on the inside that lines the antenna coming up. That's a tube, then comes down like so. This on the inside has your Gans of urine. Let's see, do I have a color for that? I think I've run out. I guess we'll use that one, which is in there, Gans of urine.
We're calling that one PP.
One PP, yes, PP. PP Gans. I like PP Gans, yeah, right. I can't write with this. PP Gans. So that's, and on the inside, that is actually going to be the heavies out of your Gans goes in there. That's the solids off the bottom. That represents the lymph of your system. Your CH3, which is on the outside of that tube, is your hemoglobin, which is your blood. The nano-coated wires that go through it is your nervous system. And so what we've done is we've made a representation of the human form inside the Rook of the maggrav system to basically set up the Starship engine, which is the power core, the power center that will later drive, even if we don't use it as a spaceship engine, it'll actually drive the electrical components that we'll be adding to later. So the inside of the tube will have a little bit of caustic, so it's going to be plus. It is going to have a little bit of aluminum, which gives you the H3. And I'm going to ask Joe right now, what form of plasma is the H3 in this system when we set it up this way?
The H3 in this system should actually create a hydrogen, but it should actually create a helium-3, no?
Yes. What form is it in?
Oh,
what physical form?
Oh, you got me off guard. I'm sorry. You caught me.
Liquid, solid, or gas?
Oh, it's going to be in a gas form. It'll
be a gas form.
It'll start off as a liquid, then it'll start dissolving it and go into a gas form.
Basically, this is your temporary H3 provider to the system. And we're trying to contain it long enough so that it excites these CH3 and then dissipates. And we create more each time the CH3 needs it. The supplier, the ping, so is caused from the H3 inside the tube. The tube is sealed. We're figuring that there's just no way that we're going to be able to permanently contain the H3. It's just going to be there and gone in very, very minute amounts, and have no idea how long it's going to work, or it's part of the details that we have to work out later on. But at least at this point, we have the gaseous state of the hydrogen in the center, pinging the liquid state of the hydrogen in the CH3, which sets up the plasma conditions around the spaceship, and giving us the lift, the anti-gravitational, all the system operations of it. This is your core engine, your static core, with no moving parts. But it's also called the static core because it's picking up the ambient static electricity, that ambient static charge that's always around you, and bringing it into a constant usable state. And it shouldn't be a runaway system at this point, because it's more a small portion of the energy, and it's created and let off. So we have a steady power source in the middle of this unit. If you have a steady power source, then we have the control to do everything else. The systems that were developed prior to this, in the Joule ringer circuits, it picked up a variety of energies in a manner that it would overload the system. It just started sucking it in and just kept going, and you end up with a thermal breakdown, and the system would collapse, and as they say, the magic smoke would leave the device, and everything runs on magic smoke. And when the magic smoke leaves, it's broken. So we don't want to see any magic smoke leaving our units right now. The only thing we want to see is, the only thing that may happen is just the tiniest, 1 or 2 molecules of H3 slowly bleeding off the top of this and providing the energy ping that drives the entire system. Okay, I'm going to stop share for a moment. So comments from you too.
I think you covered a lot of this. I think you were really specific about the core. The only thing you left out on the core was extending the hose down lower and letting it sit out the top, the center hose. So it's easier to glue it, and
okay.
And the wrap on the bottom. They're going to have to adjust that to whatever they can use, air pump hose, whatever they can get their hands on, and see what's going to fit.
Yeah,
and also we're using 3/4 pipe. We have to let them know that we weren't specific with that.
Yeah, we're still, I'm still keeping a little bit of a suspense on what the Rook design is, because it's still in R&D. We're still hashing it through. We've got a lot of the questions answered, but it's still in the brainstorming stage. We have basically the progressions of the liquids, we have progressions of the solids, progression of the metals pretty well hammered out.
And
now
we have a new way of nanocoating them too, so it's a lot easier.
Okay, and each of your coils will have to be nanocoated slightly different than what you would be thinking about. Your iron one at the top basically takes just a little more heat, depending on your source of iron for the inner core, whether it's rebar wire, which is very common, that has an oil coating on it, quite extensive oil coat.
Very hard to clean off.
Yeah, you can burn it off first or you can burn it off later. It really doesn't matter. That one, it's just you're going to take a little bit more time and get a good job on your nanocoating. I highly recommend using flame on that one, simply because you're going to have to burn off the oil that's there. Otherwise, you're going to be looking at a solvent, a degreaser, to get rid of the oil off the iron wire first, and then go into your caustics, and you're going to run into a slight problem with because it's a bimetal and you've got it in a caustic, it's going to want to react horrendously with the copper alongside it. I mean, you're asking for, your caustic is going to cause you a problem. Your center coil, which is copper, by all means, if you like using caustic and steaming method, by all means use that for that copper coil. If you're doing electrical and you can do your currents properly, remember they go in opposite directions, then you can nanocoat using plasma. Just remember your directions because it's super important. We'll be going to the next design here in a minute and start talking about plasma, but what we're actually doing in the fields. We get down to the aluminum. The aluminum, if you put that into a caustic steam solution, you're liable to lose your aluminum wire in the process. It's going to eat it up. So on that one, you may want to do a flame coat and then heat it gently several times, either on a gas stove or possibly electric if there's a shield between it and the burners, like with a cast iron skillet or something like that. You'll find that when you nanocoat the bimetal aluminum copper one, it will have a silvery sheen to it that you haven't seen with your other coils. Perfectly all right. It's just what happens when you nanocoat that one inside the other using copper and aluminum. Aluminum reacts amazingly with other metals in different ways. So be advised, you will see a different color in that one. And so you hold up your coils and you'll know almost immediately which one you've got simply by the color of the nanocoating on the outside. The center core, when it goes down into the antenna, when it goes down into your lead Gans, has to be wound the opposite direction of your maggrav coils. Okay, if it's counterclockwise for your maggrav coils, it's clockwise for your lead Gans probe going down into it.
And
assembly gets to be interesting, and we'll probably end up having to have it's like this old house type of construction. You got to put the washer in. You got to put the thread in first, and then the washer, and then the bottle, then the thread comes down onto the bottle. It's a lot of construction in the line of it's assembly. And keep in mind that you're going to have to do certain things in order when you go to assemble it, or it's not going to go together. It's in a way, it's a complicated build, but once it gels in your mind of what we're doing, you'll go, oh, that makes logically good sense. And it's in home repair, it's kind of like putting the lead Gans at the bottom would be very similar to assembling a P-trap in the drain of your kitchen sink. It's the same idea. Go ahead, Joe.
So Cleve, go ahead.
I got a question. While we're talking about that center wire, instead of just one, you're trying to find a piece of 8 or 10 gauge or something like that, what about, everyone's got 14 gauge, what about we do either a twist, like a multi-strand, 3 or 4 bits twisted together, and then we get the bottom, we can just twirl them all out. Or I was even thinking about Mike's infinity coil twists, where you can do a multi and twist it in the drill.
It's going to take a little bit of R&D on this one to see which systems work and which will do better. Some of the concepts, and we've batted it around. One was the multi-core. If it's a single wire, like let's say insulated wire that has a multi-strand, and you bring that up, each one of those little strands at the top, when it comes out, has to be capped off. Like the top of a whip antenna.
Could they go
And
in?
there's nothing wrong with it. It just means that either up and back or a cap, because it's a resonating circuit, and part of the charge comes down, goes into the lead Gans, which works sort of like a capacitor, and then when it goes the other way, if the lead is full and the stream is going up, this is your ping out, which sets up everything in motion. So it gets rid of the excess electrons, and then the slam coming in is, from what my understanding at this moment is, that slam coming back in of the static charge is what drives our whole static generator. It's that bam coming in, and that can happen thousands or millions of a time for every second. It's a really quick. It's a fast one. That's the beauty of lead, is how fast it gives and takes.
This is for a 3D renderer. Make sure when you're drawing it up, you're marking the flows coming in and the coils and to where they're catching it, and they're catching it with the coils in the wraps like we do, like the glove.
Yes. Yep.
Because I think that's going to be very important when we look the system up. Now I got to redesign my system, because the more I look at this core, the more I'm going to change this.
That's right. The more we talk about it, what happens is we start to understand the system as we build it, as we go through, and we start seeing the problems and where we can improve on it. And we're not rushing into this. And even though you're viewing this right now, you're getting, as the three of us understand, and there's actually 5 of us all on the team. We have to be at this point where we are right now to be able to go to the next step for the next video. And we'll come back, and you'll see as each video progresses, there'll be slight corrections because of the increase in understanding of the system. And we're not going back and correcting the beginning ones, because we fully understand and realize that each of you who are watching this needs to understand the progression that got us to the point we are right now. And it's, if I walked into your house and started talking French to you, you wouldn't understand. But if I started with a few voices, and a few words, then it'd be fine. I have to go. A sec. Pause.
I'm recording. Good.
Everybody recording? Okay.
Yes.
Okay. The screen that's important, I'm going to go get the photo again. And it takes a moment for this to come up, and hopefully my voice doesn't get all garbled with the system. Oh, what did I had it up, and then you guys were talking. I couldn't get you guys to slow up for a minute. Oh, where's my drawing? It takes a minute. Shoot. There it is. Okay. Okay. Why is it? Why do we sabotage this circuit every time we get to this point? And I've basically reduced down the whole system into a very simplified circuit. I've separated the gravitational from the magnetical, so that we have on this portion the magnetical, and this portion the gravitational. Okay? Keep in mind the direction of flow of the plasma through this circuit. For your magnetical, we have no problem realizing the toroid forms like this in both directions. Okay? From the bottom, comes around from the up and around the top and goes back down. This is the expansion of the toroid. You will see it collapse into a more gravitational or a collapsing portion of it as it comes in through the bottom, like so. Okay? At the equator of this, it does change its properties. The magnetical, or excuse the gravitational now, works in reverse. It's traveling that direction, which means the toroids are going that way. It's collapsing at the top in the true gravitational, as we know it, coming into the toroid, and expanding out the bottom. Let's see if I can get a different color. Do it green. Out the bottom. So it comes in, it expands out of the bottom and works its way, and it changes from an expanding gravitational to a contracting gravitational. Our heavy gravitational, if you remember correctly, was our lead Gans. Oops. Let's expand it. Oh, well, let me do that. That's interesting. Okay, we'll go back to what we had. Erase all. Remember that our gravitational, our heavy gravitational, is our lead Gans in this position at the bottom. So our gravitational pull eventually picks up all the electrons, spare electrons, and stores it in a capacitive manner in the bottom until it can't store anymore or has the ability to release it, and then it'll expand out to feed the magnetical. Okay? We've got two things going on at the same time. We have gravitational coming in, gravitational going out. Magnetical coming in at the bottom, magnetical going out, magnetical going out. We have gravitation at the bottom. It goes into it, and it releases back out. It feeds the magnetic. The gravitational on the rebound feeds the magnetical. The net effect is, because we are limiting or we're collapsing as much as we can of the gravitational field and moving it to our new center of, which would be the iron core, the center of the planet, which makes it our center. We have artificial ground in the lead at the bottom, but we have an artificial center of the Earth up in the CH3. What it does is it separates the ground, which is heavy gravitational, of the Earth from what is going to be our new gravitation, which is our spaceship, and we're changing the polarity, so from the positive being attracted to this negative of ground to the positive being attracted to the negative inside our spaceship. Our net gravitational is now no longer the Earth, but now a slight anti-gravity repelling the Earth, because we have separated what was an all earth system to a earth and a temporary earth, or a separated, it's a artificial earth. And that artificial earth is us. It is our plasmatic field. We're not bound to the earth itself. And what we've been doing the last 3 weeks, getting these videos together, is actually proving or confirming what Mr. Kesh said about negating the gravitational force. So when you're looking at your systems, when you're looking at this simple drawing, this simple concept, watch your currents so that your gravitationals are going one direction, and your magneticals are going the other. And when you set up your direction of how you're hooking up your plug and play, you've got your directional coming down in the magnetical in this direction, coming around. You're going to be catching it in its catcher's mitt with a coil. When you're doing in the gravitational side of the equation, it's traveling the other direction, and you're catching it in its catcher's mitt the other way. This is the reason why, when I erase all, that we have changed our nomenclature for circuits and how we show plus and minus. We know that if this is the direction of flow coming in, it is caught in our capacitors like so, and change the size. We know our plasmatic flow is going to be that direction. Keep your directions in line in the fields that you're working with. If it's magnetical, it goes one direction. If it's gravitational, it goes the opposite direction. And we have to keep this in mind over and over and over again. Otherwise, what happens if you're forcing your plasma backwards through the catcher's mitt, then it leaves in multiple directions. You're losing it. You want to catch it. Okay. Hopefully. Any questions?
No, you actually covered something that I was thinking of. You covered it very well. That's what I was working on before when I was sitting here. When I told Cleve to make sure when he does the 3D rendering, make sure the directional flows are correct. Because it's very easy to get confused with that. Very easy to get confused.
As I say, it's one of those spots that we ran into a couple of times, and it goes back to that same circuit that we mess up over and over again. Every time we come up to it, we sabotage it.
I have to change my core now after looking at that, because I had the wire for the top feed out to go into the mitt. Now it has to be reversed, has to catch it, which is no big deal. But it's better if they do it now than sit there when I'm done and scratch the monkey scratching his head going.
Well, I think the detail that you've given us is amazing, and it's clear, and going together with this, as you say, the series of these videos is kind of pretty easy to follow, and they build on each other, and the depth of the knowledge you're giving us is astounding. I really appreciate it, Matt.
That's why I call him a plasmateer. Yeah, no, you're right, though. The way he lays it out, it's very comprehensive. You're not sitting there going, what?
What did he say? What did he say? What's he mean? You know, you're very clear with your answers, with your explanations, and you're going to be even better with the 3D rendering.
Well, I've got enough to do to finish it off now, I reckon.
Yeah, we have to get this out. This is going to be a Christmas present for everybody.
Yeah, it's working out to be a really fine Christmas present for the people of the planet.
Yes.
And as a thought that goes along the same line, what we're teaching here and what we're pulling together is quite a few different disciplines. You know, we're standing on the shoulders of those thinkers ahead of us that dared to look at things as nature presents itself. What we're looking at is we're moving out of a split binary mindset. You know, it's like two fish in the yin and the yang circuit. One batting it's, you know, chasing the other around and trying to figure out what's going on. And if we take a look at the yin yang and we look at the two fishes in the yin yang, what we're dealing with is the age of Aquarius, which is what humanity has been in for I don't know how many hundred years, several hundred years. We're in that constellation. We're moving into the age of water awareness, the age of Aquarius, and the understanding that water is not bidirectional. It's not a one or the other. It's not a binary component. Water has three states. It exists at the same time in the liquid form, in the solid form, and the gaseous form at the same time, in the same location, in the same place, in three different forms at times. So what happens is we have a third dimension of thought, a higher plane of awareness, and an understanding that we have more than right, left choices to make. That we're dealing in a three-dimensional world, working our way into four-dimension. Because as soon as we create ideas in three-dimensional form, then they have to withstand the fourth dimension, which is time. And at our present understanding, time and space is only relative to the position that you're standing in right now in the thing that's called now. Okay? It doesn't matter 2 seconds ago or 20 years in the future. Does not matter, and it has no consequences. You only have now, which means what your thoughts and what you create in three dimension in the now changes the reality for yourself and for everything else in the universe. I cannot change the universe. I cannot change Joe. I cannot change Clave. But I can change me and how I think. And how I think and with the things that I change, then the universe has to adapt to it instantaneously and thusly change to accommodate what I have dreamt up. And that goes for each and every one of you watching this video. You change your reality in now time. Right now sets up the changes that will happen in the future. This is what's really important, and this is what's really wonderful about the new age that we're moving into. We're moving out of the post-industrial stage, which the industrial age was basically the expansion, the huge magnetical expansion. Everything was motors and everything was electric and everything was expanding. It reached a critical mass and started to collapse. The post-industrial age, which we're looking at right now in the year 2016, is a collapse of the industrial age, moving back into gravitational. The things that were created in the expansion portion are now collapsing. They're falling down. The infrastructure, the bridges, the machinery, everything that was expanding in the industrial revolution, the industrial age, is now wearing out. And we are moving into a new age and a new way of thinking, which is plasma, or in the case right now, water in three dimensions, in three directions. And so as the industry changed, going from the agrarian society into the industrial society, we didn't need buggies and buggy whips and guys that made wooden wheels. Those guys were out of a job, and new jobs were created in the industrial age. So where we were making refrigerators, we didn't need the iceman anymore. We didn't need the furrier who was making the steel horseshoes for the horses. But we now have people who are changing the tires on the cars, the people that were mining for the ore that made the cars, for the oil that ran the cars. This age is ending because it's no longer needed. We are now moving, with the help of this team and many others around the planet, to go into the plasma age. And it'll take a new understanding of what is to come. And and humans don't like change. They like things to remain the same. But in the world around us, nothing stays the same. It is either expanding or contracting. It is either growing or dying. And we can either die as a species, or we can expand our horizons and go into plasma technology, into a new age. And right now, that age coming up is the Aquarian age. And I bid you all peace.
Fantastic, mate. Thank you very much. We'll catch you later, gents.
It was perfect. You came up everything. It seemed like we got a lot in order. You really worked a lot of this out. It's amazing what you worked out. You just like to test me. I know. Building this stuff. No, I'm glad though, because now when you were explaining the core, a lot of this other stuff, I rethought the way I'm putting this assemble on this. Now I can actually put this all in. I might not even put a case on this. I might just slide this core right in the middle of these coils.
Okay, are we recording? You got it turned off?
Yeah, I turned mine off.